So what we've been talking about are concave mirrors. So for a concave mirror, then we're over here. This is the real side. So the mirror is deeper in the middle than it is on the side, so it's bending away from you. A convex mirror is going to be like this. So you're over here somewhere, and the mirror is bending away from you. So it's farther, closer to the midpoint than it is now. So a convex mirror will be like a spherical ball, a mirrored ball. Okay. So for a convex mirror, then you have an object that's outside the mirror right here, and the radius of curvature is over here. So the focal point's over here. Well, in this case, if that means the focal point is on the back side of the mirror, that's the virtual side. So that means the focal point is going to be negative. A negative focal length or negative radius of curvature means you have a convex mirror. A positive focal length or a positive radius of curvature means that you have a concave mirror. We're going to find out that that's exactly backwards for lenses. That's about the only thing that's different about lenses. But here it's going to be perfectly fine. So let's do an example. Okay, so let's say that we've got a mirror that has a focal length of minus 14.8 centimeters. So we have a focal length that's a minus 14.8 centimeters. And we have an object that we're going to put 28 centimeters in front of the mirror. Okay, so if we draw that, the mirror's going to be like this. The focal point is going to be right there, and we're going to put an object right there. Okay, so how does that work? Okay, the center of curvature is over here. Okay, what you do is you draw a line straight this way. You always draw a line straight to the mirror. It's going to go through the center, it's going to go to the focal point, except the focal point is down there, so it has to reflect off. So it reflects off that way. If you draw a line to the focal point, we can't draw into the mirror, so it hits and goes off this way. A line towards the center of curvature reflects back where it came from. Okay, so that means, again, they never converge. But if we run all these lines together in here, they actually come together at a spot right there. So that means we actually get a virtual image. Okay, so again, it's behind the mirror, so the image is virtual. You can again look for the ray diagram. The image is erect, so it's upright. Okay, and so now we want to figure out, well, in that case, just where is it? So same equation, 1 over f equals 1 over do plus 1 over di. So that means that di equals 1 over f minus 1 over do to the minus 1. So in this case, that's going to be 1 over a negative 14.8 centimeters minus a 1 over 28 centimeters to the negative 1. So di equals, and you notice right away, we have negative and negative. What does that mean? Well, negative and negative means that the result has got to be negative. And so that means that the image has got to always, for a convex mirror, is always going to be a negative number. And so it's always going to be a virtual image. So in this case, it is minus 9.68 centimeters. Okay. Well, what's the magnification? Magnification is minus di over do. So in that case, that'd be 9.6, negative 9.68, negative divided by 28. So that would be a magnification of 0.346. Now, positive means it is upright. Okay. 0.346 means it's just over a third of the size of the original object. So if I gave you the original size of the object, then you know that HI is the magnification times HO. And so you could use that to find the actual height of it. And this problem I didn't actually give you that, but this is how you would do that. And so this would be an example here of a convex mirror. And again, from this equation right here, because the focal length is going to be negative always for a convex mirror, you will always get a virtual image. And it's always going to be smaller. So the virtual image will always be smaller. These kind of mirrors, convex mirrors, will always give you an image that's smaller. It's going to be upright and virtual.